with everyone at such an amazing venue. This is joint work with students at Carnegie Mellon, Zahan Charles, Mingxiu, and Hongyi, as well as a JD PhD student here at Stanford, Mark Krass. And we're really sort of excited to share this with you. The motivation for this work is the well-documented problems of mass adjudication. A less known fact about the US judicial system is that government agencies adjudicate far more cases than all the federal courts combined. Even a single agency like the Social Security Administration hears 500,000 cases annually. And that has led to really profound challenges in the administration of justice, where going back to close to 50 years to Jerry Mashaw's work, we know that the identity of who the administrative law judge is matters greatly, and in his view, even more than the facts of the case, such that award rates plotted here can range between close to 0% to 100%, depending on the assignment of the administrative law judge, leading some scholars to decry this as a form of disability roulette. This is what the file room of a recent mass adjudicatory agency in the American system, the Board of Veterans Appeals that we're going to study here, looked like as of a number of years ago. And so that came with really profound challenges, both in terms of the caseload, wait times for veterans exceeding 5 years from the time a notice of disagreement, a notice of appeal was filed until resolution. And here from some data that James Ridgway, who used to be at the BVA, presented, the result of this kind of increased caseload was that staff attorneys had about 10 to 15 seconds per page of the record, and veterans law judges with larger staff reporting to them had about 45 to 60 minutes for review per written appeal. Such that in 2018, a survey revealed that 90% of the staff attorneys reported having inadequate time to review the record. And that is really the kind of motivation for the kind of work we're doing here. It seems to have, where we're going to look at these BVA decision texts, so all texts from 1998 to 2017, about 750,000 decisions, and we're going to focus on single issue cases, and we're going to bring in some metadata from the internal system, and also use the Harvard Case Law Access Project to combine and really figure out whether there are ways in which we can use advances in natural language processing to really help improve the accuracy and consistency of this process. For those of you who are wondering what VACL stands for, it's the internal database that the Board of Veterans Appeals actually uses to move cases along. And it literally stands for the Veterans Appeals Control object locator system, because it's literally the system that was used to try to figure out which room a file was located in. And so we've got basic information about claims and diseases spanning the years 2009 to 2017, and close to 300 identifiers for veterans law judges. And the basic way we're going to try to tackle this is to really see whether we can develop methods for better citation and application of precedent during opinion drafting, given the quality and consistency challenges in mass adjudication. So the kind of hypothesis, whether we can predict, build an ML system that really recommends citations that are specific to a case context. A little bit of motivation here is if you look at the existing kind of trends in large language models, if you turn to a model like GPT-2, you can prompt it with a statement like the following: as the preponderance of the evidence is against the claim, the benefit of the doubt doctrine is not applicable and the claim must be denied. And GPT-2 actually returns what look like pretty sensible sets of citations here that might be seen to support this statement. It respects the order of authorities as spelled out in the Blue Book. these look like roughly properly formatted sort of citations. The only small problem is these are citations to cases that don't actually exist. So there are still major advances that have to be made here. The actual kind of target would be Gilbert versus Derwinski for this particular statement about the benefit of the doubt doctrine. Similarly, another kind of example here would be a statement about material evidence. Material evidence means evidence that by itself or when considered with previous evidence of record related to an unestablished fact necessary to substantiate the claim. The kind of typical citation would be to the Code of Federal Regulations. And with that motivation, I'll turn it over to Matthias to talk about our technical approach to really solve this challenge.
Unmuting myself. Okay, thank you very much, Dan. I will present our technical approach now. And the first thing we do in our pipeline, so again, thank you for having us at this wonderful conference. It's a pleasure to be here. I'll present the technical approach. I hope my microphone's working. The first thing we do in this project in its technical pipeline is to pre-process the BVA decisions in our corpus. We do that using a comprehensive set of regular expression extractors that pull out citations to cases, the United States Code and the Code of Federal Regulations. We mask those citations in the text and forward the decisions with the masked citations to our tokenizer stage. Parallel to that, we take the raw citations that were extracted and apply a normalization procedure that resolves those citations to either the case law access metadata corpus, specifically the VET-app and F3rd reporter. We also normalize citations to the United States Code and the CFR in a way that I'll explain in a moment, and hence assemble a comprehensive normalized citation vocabulary from which we draw the relevant citations and merge the decision back after having been, after tokenization. Okay. Okay, I'm getting a message that the video doesn't work. So
we see you now.
Okay, we see me. Okay, sorry. I'll just walk back to, thank you for the pointer. This is the graph I was supposed to be showing. So again, decisions come in, we extract citations, mask them, feed things into the tokenizer, in parallel, take the raw citations, apply our normalization procedure and remerge those citations. Thank you for raising my awareness to this issue. To illustrate the citation normalization, we take case citations which we identify by the reporter name, the volume, and the page number, and we use case law access metadata corpus to identify a unique ID that we can resolve this case to, and all versions of referring to, say, Dekmatich v. Brown, are then resolved to this lemma. Citations to the CFR and the United States Code are decomposed into the prefix and the tail, where the tail is then segmented into individual elements. And so a full citation string becomes a list of normalized atomic citations. And using this procedure, we're able to boil down the 97,000 unique citations in our training data to about 4,300. 4,000 of which are normalized according to this distribution. We get a total normalization coverage of about 98.5% of the 5 million instances in our training data, which we think is fairly good. So the formal definition of our task is then to take a tokenized context segment from our decision, which may include already some special tokens such as paragraph breaks or other citations, and to predict in a delimited forecast window, the index of the next citation in theirs, in this case here, 132. As Dan has mentioned, this could be considered a text generation task. However, as we've seen in the example before, it's hard to generate full citation strings. So we treat this as a classification task, which is the slightly easier task to make incremental progress with. Of course, citation recommendation is a well-studied problem. For general and scientific literature recommendations, predominant approaches are collaborative filtering, graph-based and context-based models. There's also some work being done in the legal AI sphere, specifically often in conjunction with legal citation networks. There's also proprietary systems such as case text parallel search or Thomson Reuters quick check, etc. I'll refer you to the paper for details, but I do want to acknowledge the basic collaborative filtering and context-based approaches because this is what we are using in our model. As a baseline, we use a collaborative filtering model. So instead of one receiving, being a user and receiving, say, movie recommendations on Netflix, you are opinions here get recommended citations. To do that, we treat a case opinion as a bag of citations, which allows us to compute distance measures to other cases, and then additional recommendations are scored according to this distance metric. And the metadata Dan has explained is added using is aggregated using an SVM ranking module from which we then predict the citations. Our next model then adds textual context to it by representing the text preceding the citations as a bag of words in a TF-IDF factorization, and we recommend citations by computing similarity from a query context to the contexts in the training data and the citations that follow them. Again, metadata is added to the model via as part of an input to an SVM ranking module. Our first full-blown NLP model is a BiLSTM, which reads the citation context back and forth and gets its encoding concatenated with the metadata and fed into a classification head, which then predicts into the vocabulary size. Similarly, we take a pre-trained English pre-trained Roberta model, which is a stacked transformer architecture, which encodes the context, concatenates the encoding with the case metadata again, and feeds it into a classification head, which projects into the vocabulary size. This brings us to our results. So we evaluate recall at 1, 5, and 20. So the probability that our model predicts the correct citation in the top 1, top 5, and top 20 site recommendations. And our primary results are in the neural models are for context sizes of 256 and forecast sizes of 128 tokens. The first thing we see here is that our neural models, of course, unsurprisingly outperform our non-NLP models with recall at 1 in the mid-60s, recall at 5 in the lower 80s, and recall at 20 in the low 90s. We also observe that the Roberta model, despite being pre-trained, only does consistently perform better than the BiLSTM model, but only by at most 1%, and usually within ±2 standard deviations across our 6 test folds. So pre-training, the benefits of pre-training are marginal here. What's also partially not shown here, and I would refer you to the paper for that, is that there is no, the benefit of metadata influences training, but there's no consistent benefit in adding it in the different architectures. This is an area where we intend to conduct research in the future. And again, the details of the results that we observed are in the paper. If we take our best performing Roberta model and we run it over time, we observe that the model performs equally for case regulation, equally well for case regulation and statute citations, and also fairly stable across time, with this little oscillation down here, we conjecture being due to a change in veterans law. We also observe the decline of the model performance as the distance to the citation in the forecast window increases. This decline is, of course, more sharp for recall at 1 than it is for recall at 5 and recall at 20. Still, so we do see some evidence here that the model is probably engaging in a fair amount of memorization of textual context, specifically for verbal and verbatim quotations of the sources before the occurrence of the actual citation. Still, the fairly gradual decline of recall at 5, which is sort of we consider the most representative use case scenario, suggests to us that the model does learn some amount of long distance patterns. and that it's a promising approach, technical approach to treat citation recommendation, at least in part, as a classification problem and benefit from supervision signal, rather than treating it just as a pure encoding similarity retrieval model, a retrieval approach. Finally, we did an ablation experiment, and Mark Grass produced this graph here. First, please look at the right half here, where we compare models that predict 64 tokens into the future and models that predict 128 tokens into the future. So the upper quadrant is easy and the lower quadrant is hard. And we can see that if we give the model more context, larger context as we move to the right, the increased slope here shows us that the model performs better the more context we give it. And for the easier task up here, the more flat slope here shows us that for predicting 64 tokens ahead, giving the system more context doesn't help as much. The only other piece of information here before I hand it back to Dan is if you compare this to the left half of the model of this graph, where we graph models that do not have access to metadata, we notice that if you are in the hardest task, which is you predict 128 tokens from a short context, actually, if you give the system metadata, so we're comparing these two spots, performance improves a bit, which means that if the model has to predict very far in advance and has little context, it may actually benefit from some metadata, but this benefit disappears more or less the more context you give it. And with that, I will hand it back over to Dan.
Great. If you just go to the next slide, Matthias. So we think we've shown the utility of this kind of a context-based citation recommendation system. And it's particularly notable that in the kind of more sophisticated models, the benefits to adding metadata were really kind of marginal. There are, of course, lots of other really interesting legal implications when we think about this kind of a system for AI-assisted adjudication, both in terms of the due process values and the decisional authority. That is, do you start to, for instance, reallocate decisional authority for locating relevant precedent away from the staff attorneys or veterans law judges toward the engineers who are building out a system like this, which of course relates to the much broader conversation that many of us are engaged in terms of algorithmic governance. If you go to the next slide, Matthias, I think the kind of concrete use case here really does come from the Social Security Administration, where Gerald Ray, who was head of the Appeals Council, had started to hire attorneys who also happened to have data science and software engineering backgrounds, had them learn the adjudication process, and then had them start to build out simple prototypes that led to sort of the first NLP-based error detection system, where staff attorneys and judges can input a draft decision and get around 30 quality flags, such as the one depicted here, that starts to use both heuristic and machine learning ways of spotting internal inconsistencies within the decision, like the one here. If you could go ahead and advance to the next slide, that, of course, then is what is one of the biggest kind of potential upsides to this kind of a system, is that one could go back to the original diagnosis provided by Jerry Mashaw of these kinds of NLP-based systems as really fostering better forms of bureaucratic justice in the kind of internal management system that Professor Mashaw had talked about, which connects to some of the broader work about the ways in which government agencies are starting to rely on forms of artificial intelligence to improve governance functions within the public sector. With that, we'll leave it open for questions. I think we can probably unshare the screen. And Lara, I don't know if you want to take over.
Hi, Professor Denhu, and hi, Professor Matthias Grabmair. Thank you so much for your presentation. It's a really interesting paper. Now we are officially open for questions. Until now, we don't have one, but I think I think our audience is just writing one. Just a second, please.
While that's happening, and maybe to give people a little bit of time to kind of get their questions together, Matthias, I think this has been just a really wonderful collaboration because it's got kind of the direct collaboration both on the technical side and on the domain side. But maybe, Matthias, do you want to? One of the things we didn't present was sort of some of our thoughts on like next steps of where to kind of take a system like this. So I don't know, I'll throw a question over to you, Matthias, until we get a question from the audience. What do you think? What are you most excited about in terms of next steps?
Thank you. I also I'm very grateful for this great opportunity of collaboration, and everybody learned a lot over the course of this project. Technique-wise, there's of course a lot of things to be interested in here. Immediate next steps would be similar, Dan, to your group's other paper, would be to evaluate how much domain-specific pre-training would, for example, help models like this. The other thing we have been looking into is generalizing to the problem, again, now that we've established with some success that next citation prediction can be treated as a classification problem, can we make the task harder and move one step towards text generation in a way that does not suffer from the susceptibility to generate, say, implausible citations or other distractors that are not perceived as useful by the user.
Yeah, I would add one thing to that as well, which is concept drift, which is if there's a change in precedent by the Court of Appeals, we have not yet focused on a system that really is able to detect that and to recommend substitution from historical precedent that, for instance, might have been overruled into new precedent. I think that's going to be a very important one to actually have a system like this operate in practice.
Okay, thank you so much. We now have one question from our audience, and they ask, Mr. Hu, could you please elaborate for us on how accessible this kind of technology would be for the use in countries that don't adhere to the common law? I think the audience is asking about the civil law.
Yeah, it's a great question, and I think probably Matthias may actually be better situated to answer that, since he does have familiarity with the German system. But maybe one thing I'll just start off in terms of an answer is that we may have glossed over this a little bit too quickly, but this is actually an interesting adjudicative scheme because it's sort of has elements of the common law, but a lot of this is regulatory law. And so we had three different classes of citations: statutes, codified regulations, and case law. And so, you can kind of think of the task in a more civil law system as being one to kind of help adjudicators identify the right code provisions. And I think that's where a lot of the kind of pre-processing that Matthias described becomes really important. But Matthias, you have more familiarity with a different, a non-common law system. So I'd be curious to hear your thoughts on that.
Thank you. I agree with your first answer, and would like to emphasize this just a tad more, in the sense that our system is in a sense source agnostic by predicting solely based on use patterns. So we're not restricting it to cases, or it's not restricted in its current form to just cases or statutes or regulations. And in a civil law context, one could think about the fact that the system would pick up on common commentaries, for example, or other kinds of regulatory support documents, preparatory works, and so on and so forth, that would be cited in civil law context than you would cite precedents. So I think the basic architecture applies. However, I think it remains an open research question, or a sort of proof of concept question, whether legal reasoning that contrary in civil law countries, that contrary to common law, doesn't take as much recourse to specific facts of prior cases. So generally it will be more terse. There will be sort of less borrowed language and things like this, and less verbatim quotations. So the task, the data distribution will change, but the basic task of predicting a source in a textual context will be the same, even if what's in the context will be a different kind of discourse.
Okay, great. We also have another question from Mr. Hannes Westerman. The question is, how the mentioned changing of precedents and maybe the discovery of new general principles of law may affect the processing of the tech? How the mentioned changed of precedents and maybe the discovery of the new generation principles of law may affect the processing of the tech?
I think the way, at least I'm interpreting that question, is as related to what I had mentioned earlier to concept drift. That is, suppose there's a change in precedent by an appeals court. How does one build out a system and build out the architecture to ensure that it doesn't, for instance, keep recommending a case that has been overruled? And I think what would, of course, be very, I guess I have a couple of thoughts on this. One is that it would be very valuable to start to build in the kinds of citation signals that we see in, commonly used research tools for lawyers. But another really interesting source of information to exploit when those tags may not necessarily exist for a body of veterans law, for instance, would be to actually leverage the fact that there are real quality differences in adjudicators. There are some adjudicators who pay a lot of attention to immediate changes in the law and are much more rapid in their adoption of new precedent. And that would be a very interesting thing to kind of explore, given that we see the identifiers of the different adjudicators, and could potentially start to understand which adjudicators are the ones that are signaling to you that the historical recommendations may no longer be accurate. Matthias, I don't know if you have other thoughts on that front.
I agree. So if you in the paper there's a graphic which I'm not showing you showing up in the interest of time, where we observe that it does not for many instances in the data, the system doesn't need a lot of training examples in order to predict the use with the citation with high accuracy, with high recall. So I do think that the data threshold of how much does something need to be there in order for the system to pick up on its use can be, depending on how varied the language is, relatively low. So I think we end up with this sort of cold start. So Dan calls it concept drift. From a machine learning standpoint, I sort of call it the cold start or sort of sudden stop problem, where something used to be, we should predict something up to now, and now we need to stop doing it. And we didn't see this before, but all of a sudden we now need to start predicting it. And I think this is in part where, and I agree with Dan entirely, where I think a merge of language-based pattern recognition, a hybrid approach of language-based pattern recognition with some intelligently curated metadata, structured metadata that is simple enough to be maintainable, but expressive enough to be useful for a model. I think that's where we want to go in the future.
First, we have a question for yesterday's presentation, and this question, let me find the question here. The question is, you are mentioning a change in the law as
Andre, do you want me to try to read it? I think this was a question from Kevin Ashley, who asked, you mentioned a change in the law as possibly causing a jag in the graph of results. Have you identified a specific change in the law?
Yeah.
Yes, so I'm happy to take a stab at that question. We did sort of identify two major sort of spikes in the accuracy of, or in the sort of recall rates or performance in our model. One was in the early 2000s, where there was a big spike in case recall. And one is at the very end of our study period, where we see a bit of a decline in case recall. And we sort of have explanations for both, but I'm not sure that either of them, or at least the second one, relates to a change in precedent. So the first jag, the big spike in recall, we think that has to do with a change in the law that came as a result of the Veterans Claims Assistance Act, which created a bunch of new procedural requirements for the Board of Veterans Appeals and the Veterans Administration in their duty to assist applicants for benefits. And over the subsequent years, there were a bunch of decisions interpreting the agency's responsibilities under that act. So in particular, there was this one case in 2002 called Quartuccio versus Principi, which changed the standard for how the VA had to notify claimants of the agency's position on their case. And when those decisions came out, it was basically found that all of the letters the VA had sent out were defective at the same time. So there was this process by which a whole bunch of decisions were basically issued at the exact same time and for the exact same reason, which is that they shared the same procedural defect under this new decision, Quartuccio versus Principi. And so that explains sort of the spike in recall, because you had a bunch of sort of form decisions that were all saying the same thing. So those were easier to predict. And then the decline in recall at the end of the series, we think that just has to do with the sort of cold start issue, which is that newer cases are cited fewer times, and so they're a little bit harder to predict. So hopefully that answers the question.
Okay.
I think that was a nice answer, Mark. Maybe just to chime in a little bit there, because I think it relates to a question that was asked during one of the earlier panels about the interesting modeling challenges going forward. And we think it really does center on the cold start problem, as Mark described it, or as a form of concept drift. That is, if we can show that there's very good performance of a system like this when the law is stable, what do you do when something like the Veterans Claims Assistance Act is passed that may affect the sort of kinds of cases that statutes and regulations that one should really recommend? And that to us is a really exciting path forward of how one builds in that kind of adaptability into a system like this.
Okay, we have another question for you. What is the reasoning for including a forecast in the prediction as well as the specific citation?
I'm happy to take a stab at that one. I think it's a good question. So people may remember the part in the presentation where we kind of give the example data instance where there is context, and then there's a forecast window which will include the citation. And I think this question is asking, why not kind of, in a sense, simplify the task and take the context all the way up until the citation token and only do the prediction of the kind of next token. And I think the reasons here really, I think, are twofold. The first is that, as a practical matter, what we're envisioning is a system that can really help with this broad challenge of mass adjudication, where staff attorneys or veterans law judges have to process a huge volume of cases and need real-time feedback that can help them in the writing process. And so that doesn't necessarily mean that you go up all the way until you've written a legal proposition and then you're finding the citation for it. It can be anticipatory. So in a sense, we're making the task harder here, which is sort of maybe the second point here, which is that we want to make the task harder, because if you already had quoted from a particular case, for instance, in a sense, it would be not very useful to have the citation recommended, because you've obviously pulled a quote or a proposition from somewhere already. I don't know if, Mark, you have anything else to add to that question.
No, I think that's exactly right. I mean, I think the tricky thing here, this is, from earlier comments on this paper, people have pointed this out, is by the time you get right up until the citation, frequently you will already know what the right case is, because you couldn't have written the last sentence unless you did. And so forecasting farther out is really, as Dan said, about sort of improving the use case for this technology for people who are actually exploring the right legal standard that they should be using, rather than just sort of citing for a proposition that's already correct.
It's, to us, also probably one of the really exciting future tasks, which is to not just provide citation recommendation, but to ideally also provide contextualization of that citation. So for instance, if we thought about this as a language generation task, could one predict the kind of parenthetical statement that would show the relevance of a case citation to the particular case at hand? That's another really exciting direction to go in, I think, with generative models.